All right, so it's 11:30, enough of this. So amazingly enough, this talk is about cardinality estimation. And the story behind this is in SQL Server, they decided about 2010 that they could have extra engines. They made up a nice engine that everybody liked called Power Pivot, and they made it part of Excel. And then it was such a big hit that they decided that they could take this engine, and really SQL Server could afford to have two engines running side by side at the same time. So in 2012, they ported Power Pivot to SQL Server and analysis services. And in 2014, they decided they could have an in-memory engine at the same time. The problem is that all these features are enterprise features. And everybody always asks, well, what are you doing for everybody? And so what they did for everybody, which is what they always do for everybody, is change something about the query processor so it does query plans and query processing better. The real query processor that everybody uses. And so they decided this time around that they would fix the cardinality estimator, which is the part that basically estimates how many rows affected you have for a query for each iterator. And so that's what they did for everybody else. So there really is only three big features in SQL Server 2014, and this is the one for everybody. Of course, there is also, and I'm doing a talk this afternoon about the one for Azure, right? Since the CEO came from the cloud, right, the new CEO of Microsoft, and even before he came from the cloud, everything in SQL Server, everything in Microsoft had always had some new feature to do with Azure, right? To sort of force people to go to the cloud. So there. Oh, I can't hear it, that's all. The open there. Never mind, I might be on camera, I won't do that. Okay. So anyway, tonight I'm going to do a talk about cloud. And if you're going to do SQL Server in the cloud, do you want to do SQL Server in a cloud VM? Or do you want to do SQL Server in a Microsoft Azure SQL database? See, I got it right that time. Anyway, this is about cardinality estimation. And this to me is sort of the most fun, because this is who I am. I work for a company called SQL Skills. You might have heard of SQL Skills. I actually work with them. I'm a partner of SQL Skills. And if you've heard of SQL Skills, you've heard of Kimberly Tripp or Paul Randall, or maybe Jonathan Kahanis. So I work with them. Have my email address. You can write me mail about anything. I call Twitter my 140-character lobotomy, because you have to speak in 140 characters. It's like writing haiku for everything, right? But I'm on Twitter because Paul said I should be. And really, it's true. He said, you've got to get yourself out there more. You've got to be on Twitter and Facebook. And it's like, no, I hate Facebook. I'll try Twitter. It's all right. Right? And when Klaus writes all those nice things on Twitter, it's like, you know, I read them and it's like, oh, cool. I'm glad that he wasn't offended by any of the stuff that I said last night. But anyway, so I wrote some books once upon a time, and then I got busy and I didn't write books anymore. And this time I actually wrote a chapter of Kayla Delaney's book. I was honored that she would let me write it. But I deal with things that some people consider to be esoteric, like spatial indexes and XML indexes and full text search. And so that's what I wrote the chapter about. Anyway, you can see the internals of how they work. I like internals. All right, so we're going to define what cardinality is. I'm going to go through a set of cardinality estimates that are done using statistics, and then we're going to talk about why they bothered to change the cardinality estimator and what they changed it to. Then the part of the thing at the end is about something that only Bob is interested in, which is the fact that you can trace how the cardinality estimator works. And so if your estimation is wrong, you can see why. Right? So I like to trace the cardinality estimator, and I've spent way too much time doing this. You can also correlate the trace of the cardinality estimator to the cardinalities that come out of the query plan. And you can see these particular calculations actually showed up here in the query plan, which I think is way cool. You may not, or you may like this. Okay, so I actually decided to look up cardinality to make sure that I got it right, and I looked it up in Wikipedia. And Wikipedia came up with two things that they couldn't disambiguate. And it ain't this one, right? That's not what I'm talking about, the relationship between two tables, like one-to-many or many-to-many. But it's the uniqueness of values contained in a column. And actually in the SQL Server query processor, or the plan creator, is how many rows will satisfy this iterator for any of the iterators in the query processor. And query plan optimization depends on this. So this is a pretty important part of SQL Server. The query processor, to figure out how many rows are going to be affected, uses mostly statistics with all the limitations of statistics. For example, we'll see statistics contain a density statistic and a histogram of distribution. But if you have multi-column statistics, you only have, oh, here comes the guy. I hope I don't have to start all over again. We'll see. Hello. I'm talking without you in front of a microphone, without a microphone. Did you want me to start again?
No, you carry on, it's fine.
Oh, okay,
Maybe
thanks.
it's like a different system. I just wanted to, I got delayed, I took the chip off the internet.
Oh, I don't need it this one, this time. No, don't need it at all. So, it was the week afternoon that I was upset about, or not upset about, wondering about, in the one downstairs.
All right, well, I'll shut up and get out.
Oh, that's okay. Well, nobody's taping this one, but that's good.
Oh, it is. I think that it's been set to record already, but you're not.
Oh, lovely.
It's just been running out there.
Oh, so recorded when never mind, I didn't do that because I thought they might
I think you said you don't want to be broadcast.
See, I don't.
You know.
Thank you.
All right, thank you.
So we're going to go through a series of cardinality estimates using statistics. And basically, one of the limitations of statistics that I was sort of getting at in stages was that if you have multi-column statistics, there are only histograms of distribution for the first column. So if there's any sort of correlation between the columns, like you have a city and a state and a country, the cardinality statistics won't reflect that. And also they use constraints. So if you have an equality predicate, right, where ID equals a number, and they know there's a primary key on it, then obviously they'll estimate 1. What they don't do, surprisingly, in the old cardinality estimator is if you have a foreign key, they don't assume that the foreign key values exist if you're doing an inner join. So imagine I have a foreign key between A and B that says, if I have the corresponding value in B, it must always exist in A, right? And I have 110,000 rows in B. Basically, they estimate less than 110,000 rows in A. They're not looking at their own constraint, right? So the cardinality estimator here fixes this. Not an example of this. It is somebody else's example, just to be sure. I mean, it has their name on it and everything. But I thought it was a cool example. I will ask them if I can use it someday. So they also use heuristics. And heuristic says, if I don't really know and the statistics aren't good enough to tell me, I have a guess, basically. It's not a guess, it's an estimate. So they always use heuristics, for example, for XML queries. If you have XML, they don't keep track of how many elements and attributes you have with certain values. So if you see an XML query plan, you always start off by guessing 50. And then the second iterator in always guesses 200. And by the way, this changes with releases of SQL Server. So they just sort of have hard-coded guesses. The one that everybody's most familiar with, and I can prove this to you using the cardinality estimator here, is the fact that if you have an inequality predicate where they don't know what the value of the thing you're comparing it to is, so where x is greater than, and then some parameter, right, and they don't know the value of the parameter, for that they actually guess 30% of the rows. And that's a well-known, I always thought it was 1/3, but that's a well-known heuristic guess that they make, and I can prove that to you in the cardinality estimator trace. Estimates in cardinality estimation in general are based upon a set of basic assumptions, and some of the basic assumptions have changed over time. Some of them are actually changing in this release. So I want to look at a couple of the assumptions. One of the assumptions is, of course, oh, I have a whiteboard. One of the assumptions, of course, is uniformity. So if I have a histogram of distribution of values, they always assume, they say, well, this is the first conference I've ever had a whiteboard, and I don't draw, so I don't draw slides, I don't draw pictures and slides, and I've used this every time so far. And you'll see why I don't draw pictures and slides. So basically, if I have a histogram of distribution, they assume it's going to be regular, like this, and it's going to be flat across the top. Now, of course, most histograms of distribution sort of go like this, and they're not exactly flat, you know. And so if they assume it's going to go like this, it's going to offer these values. But they always assume the uniformity of distribution. The worst case is if you actually have a histogram that goes like this. And this is called a guard row in the literature. And basically it's because you have a uniform distribution for most of it, but totally different distribution for one particular value. For example, take a pension calculation system where most people don't have a pension value yet. You have to work for my company for 5 years before you can get a pension. So most people have a value of 0. But amongst the people that have pensions, it's uniformly distributed. So for that, in 2008, they introduced filtered statistics and filtered indexes. So you could have 2 indexes, one that filters this out and one that filters this in, and they'll use the right index. So anyway, that's the uniformity of distribution assumption. There's another one called the containment assumption, which says if you're querying for something, you expect that it's going to be there, right? So I'm not querying for something that I know is not going to be there. So the cardinality estimator can assume that for column equals constant, the constant actually exists for that column. Now I'll do another demo that actually will show you that that's not always true if you have ever increasing values. And then for net join, the value of foreign keys exists. I already talked about that one. Finally, there's the one that I call the third normal form assumption. Anybody remember the third normal form? What's the third normal form say? Oh, I don't have internet. I could bring up Wikipedia. It's not enough time. But basically, the third normal form says that columns that are non-key columns only depend on the key. They don't depend on each other. Of course, with the city, the state, and country, and zip code, that's kind of silly. They all depend on each other. But the cardinality estimator assumes independence. There is no dependence between columns in the same table. So for example, if I have 2 columns, city and country, and the city is London and the country is England, and 1/10 of the people come from London, England, so 1/10 of the people come from London and 1/10 of the people are England in the same table, they assume that 1/100 of the people come from London, England, and that's a completely wrong assumption. Most of the time, no, this is correct because that is what the third normal form says. Okay. You're supposed to define according to the third normal form, or people will get you. So I'm going to go over a cardinality estimation example that uses statistics. And basically, there's a couple different kinds of statistics, and I'll just show you the statistics. If you've seen statistics before, you're bored, it gets better. But these are basically the 4 ways that SQL Server will estimate with statistics. So there's a Northwind database. There has been since the year 2000 where they ripped it off of Access. And I can actually go to the Northwind database, he said. Oh, why don't you just bring up the demo? That's a good idea. Okay. So this one is a show statistics demo that I do in all my classes. It is mine. Ready? I've got 2 that aren't. All right. So, go away. So, for good. Okay, in the Northwind database, there's a table called the orders table. Now, it's a well-known fact that all Microsoft sample databases are over-indexed. And for 830 rows in the orders table, they have 8, 9 indexes. Be that as it may. The one we're going to look at is the order date index, which has 2 columns in it. Order date, which is the index key column, and order ID, because all non-clustered indexes have a copy of the clustering key. Sure. So we're going to do queries against the order date. So before we do that, we want to make sure we're up to date. So we'll update all the statistics. And this is just to show you that although most people think of DBCC show statistics as the only way you can get statistical information, there's now a really nice metadata table called sysstats. It doesn't have as much information as DBCC show statistics, but you can certainly get them. There we go. And there's a statistics object for every index, and if you have auto create statistics, anytime you have a where clause with a column, they will create statistics for that column. So you didn't even have to ask them. But you get one for every index because they figure as long as they're making the index, they'll count things. So we're going to look at these statistics for the order date. And actually what I want to do is I want to put that into a different window so we can keep those up while we actually do the queries. So if you have seen statistics before, then you can be bored. If you have not, then I will show them to you now. So the statistics actually usually contain 3 types of information. And this is the general information at the top. There's 1 row of that. And this is the density information in the middle. And this is the histogram of selectivity or cardinality at the bottom. And so at the top, you see the name of the statistics, the last time they were updated, which is nice, the number of rows in the table, and the number of rows in the table that they sampled. So normally SQL Server will sample rows because they don't want to go out and read 1 million rows just to count them. how many of these and how many of those. However, if you have less than, I believe, 200 pages in your table, then SQL Server will sample all of them. Also, if you have an index, they're creating the index, so they'll sample all of them during a create. However, during an auto-create statistics or during an update of statistics in an index, they actually sample by default 1 over log n, where n is the number of rows. So 1 over log n is the algorithm, the last one I know, that they use to figure out how many rows to sample. Notice in this case, we've never updated this index since it was created, and really they sample all the rows. But that's how they decide how many to sample. If you actually maintain your own statistics, you can tell them how many exactly to sample, either in percentages or in a number of rows, whatever you like. Or you can say full scan, which says sample them all. Okay. So there's the histogram of distribution down here is defined as a maximum of 200 steps. And it doesn't matter how big your table is, you always only get 200 steps. Here, notice with 830 rows, you actually have 188 steps already. This one, I don't know why this is here, because this is wrong. This density, the density statistics are down here. Every time you see this in the books online, they say ignore that. It's like, why did they take it out, right? Average key length is only useful if it's a bar chart key, and we have a date key here, so it's going to be 12. Also, there's a third kind of statistic, or a fourth type of statistic, no, third type, that you only get if you get string columns. And I can show you an example of this later on, right now. And this is called string index. Have you heard of the string index? There's an algorithm called the tray tree algorithm, either TRIE, which I believe it is, or TREI. And what a tray tree is it's an algorithm that they use against characters to figure out which characters come close to which other characters. So this index is actually used if you have a wildcard that's not a trailing wildcard. So if I say, if name is like B %, I'm just looking for all the people whose name starts with B. If I say %, B, then I'm looking for all the people that have B anywhere in the name. Well, that's where they use this particular index to see which characters are next to which other ones. And this actually gives some pretty good estimates, but obviously it can't turn an index scan into an index seek. And then you can seek on a non-trailing wildcard. Okay, and this is the string index. If you have a string column, you always get one. And if you don't, you don't, and you can't turn them off if you have a string column. Okay, and then I talked about filtered indexes a little bit. They have filtered statistics, and you can actually make filtered statistics without a filtered index. In this case, we don't have that. If it's a filtered index, it tells what the filtering expression is, and then how many unfiltered rows we have. There's some limitations to filtered index statistics though. Basically, SQL Server will update the statistics every so often. And so often is defined as 5,500 rows and 20% of the rows in the table change. And so with a filtered index or filtered statistics, they actually update based upon the percentage of the base table that changes, not the percentage of the filtered rows. And so sometimes it doesn't update often enough, sometimes it updates too much, but at least they have them for now. There's always been a request to fix that. So the first type of statistics they actually have, if you don't count the tray trees, are the density statistics. And density is defined as 1 over the number of unique values. And so in this table, there's actually 830 rows. So if I do a select distinct, you can see that that's, I believe, 480 rows are unique. So when I did that the first time, and I'm going to do it now, I took out my calculator and I said, okay, 1 divided by 480 is equal to, and it's 002083333. And so if you go over here, they're exactly right. Right, 0208. Like, bring the magnifier up, please. Here we go. I talked to myself during, there it is, 002083333. So now you know where you've got that. And because this is a non-clustered index, it contains a copy of the clustering key, so they will also have a density statistic that includes the clustering key. Well, if it's the clustering key, you know it's unique, and so that number there is 1 over 830 by definition, so the density. And we'll see where they use density coming up. And then finally, what you have is the histogram of distribution. Remember, they try and make the distribution not so that the space in between these buckets are the same, but actually the number of rows in between these buckets are the same. Now, they can't do that as well as they like, because you might have a lot of the same value, and it's either got to be in this bucket or this bucket, right? If I have a lot of people with zero pension, there's only one bucket I can put it in. There's only some uniform I can make it, okay? And so for these particular statistics, they have what's called range high key, and in this case, row 1, range high key is the number of rows before July 4th, 1996. In this one here, range high key is the number of rows in between the 8th and the 4th. So, I'm sorry, say that again, that's completely wrong. Range high key is the number of rows that have the exact value, July 4th. Turn the microphone off. July 4th, so there is actually one equal row, right, on July 4th. And then for July 8th, there is 2 equal rows on July 8th. Great. So what are these range rows? The range rows are the number of rows between. So basically there is 1 row on July 4th, 2 rows on July 8th, and 1 row between July 4th and July 8th. Where is it? They can't tell us. That's all we can get. Now, we can get the number of distinct range rows. So this one has 8 rows in between the 8th and the 19th, and you could assume that they're uniformly distributed. But one of the ways they sort of give you a hint as to whether or not they're uniformly distributed is how many distinct ones they have. So out of 8 rows that are between the 8th and the 19th, they're all different. And so that would make a better estimate based on whether or not they were all the same. And then average range rows is just to divide these two and get this. So that's what you get for every cardinality bucket, and that's what they use to estimate. So let's do some estimation, just so you don't think I'm making this stuff up. All right, so here's a query. Oh, and when I do this, I always have to explain about this query. So what's the 1 equals 1 at the end for? So SQL Server will actually do something by default, and you can't turn it off normally, called auto-parameterization. If I have a query that uses these hard-coded values, what they will do is change it into a parameterized version. And if they change it into a parameterized version, then I'd always be using the same query plan, which is usually a good thing, but in this case, I want to calculate exact values for you. So what do you mean by auto-parameterization, Bob? If I go look at the exact plan here, notice I have hard-coded numbers here, but if I go and look at what they're executing where order date is greater than or equal to @1. So they made that automatically into a parameterized query. They make up a query plan for it, and regardless of whether or not these numbers change in the future, the query plan won't change. It's for query plan reuse. The problem with that is, of course, I want them to change to illustrate things. So there's actually 2 ways that they can automatically parameterize. One is the default, called automatic parameterization simple. And in simple, they will only automatically parameterize 1 table. If you have a 2-table join, they won't parameterize that. Auto-parameterization simple. And there's a very great limit to what they will automatically parameterize. But the 1-table query with the where clause and between clause is one of the things they will. There is also auto-parameterization forced, and you can turn this on a per database basis, or you can turn this on with a query hint. And when you use auto-parameterization forced, they will auto-parameterize everything in sight. So the only thing they won't is a having clause, right? And you can see that sometimes the rules are in the books online, but they stopped, I believe, putting the rules in the books online because they reserve the right to change the rules at any time. So people can quote you parameterization rules and they could be wrong. Anyway, I would do it. So there is auto-parameterization simple and auto-parameterization forced. Well, where's auto-parameterization off, right? Because I don't want them. And there's no auto-parameterization off. But there was an MVP for SQL Server in Sweden named Erland Sommerskog who figured out how to turn auto-parameterization off. And the 1 equals 1 trick will do it. So if I do this, I'm going to get these exact numbers, and I'm going to get a plan for these exact numbers there. So now you can see the query that he's executing does, well, actually execute the right thing, Bob. There. Yes, right here where it's not true. Okay, there. Now we're actually estimating with the real numbers, and so let's go and calculate these ourselves. So we want order date between the 8th and the 19th. And remember that the between is inclusive. So on the 8th, we have 2 rows. On the 19th, we have 2 rows. And in between the 8th and the 19th, we have 8 rows. So how many rows will he estimate? Well, 2 plus 2 plus 8 is 12, sure. And if you look, that's exactly how many he estimates, is 12. There. So estimated number of rows is 12. Actual number of rows is 12. You can figure that, right? So let's give a little bit harder problem to solve, which is let's do something that isn't based on the range high key. And this is, of course, between the 9th and the 18th. Now, these are dates, and all these dates have 0 time, but in real life, the dates are not guaranteed to have 0 time. So because between the 8th and the 19th, there are 8 rows, he doesn't necessarily estimate 8 rows, because there could be some that were, actually he could estimate 8 rows at that point, because there could be some that were not quite in that range. But in fact, what he will estimate, he said, is 6.90909. Now notice that once I'm doing that demo, and notice he does get, there's the estimate and there's the actual, and it's a little bit off. Now, it's interesting that, notice that doesn't jive with my own notes. Right, my own note says that it estimates 6.745, and why is that? Because of the new cardinality estimator. So we'll turn off the new cardinality estimator later on, and we'll turn it back on again, and we can see how much better it is. And by the way, somebody, every time I do this talk, raises their hand and says, well, if it doesn't change the query plan, it doesn't matter, right? And it's like, yes, that's true. If it doesn't change the query plan, the fact that the cardinality is better or worse doesn't matter. They're still doing the thing the same way. Really what you're looking for is query plan changes. But it's nice to see that they can estimate the right thing too. By the way, if they estimate closer higher because of the new cardinality estimator, and you're one of those people that actually looks at query relative to the batch, so you want to stop that. If I do 2 queries side by side, we're in the same batch. By the way, I can put a go between them. There we go. People will use this to see which, with equivalent plan, with equivalent queries, to see which plan is better by looking at the query cost relative to the batch. Well, if in the new cardinality estimator, I estimate 7 rows, and in the old cardinality estimator, I incorrectly estimated 4 rows, it actually thinks the old one, even though it's worse plan or worse estimation, is a better plan. Why? He thinks he's going to get less rows, right? And so because he thinks he's going to get less rows, it's a better plan. Well, of course it really isn't. He's misestimated things. So don't say, oh, it's worse because it produces a higher query plan. Well, if it's closer to reality, it's a better estimate, right? That's sort of obvious. Okay, so that's a couple of those. So what we've gone over is, let's see, the range high key, which is the best if the thing lives on range high key, and average range rows, which is the second best. Now, what about density? When do they actually use density statistics? So if we go over here, he said, oh, come on, there we are. And suppose that we have a query that looks like this. And so how would I think, maybe? A lot of people think this, I'm surprised. How would I think that they estimate this query? And so everybody will always say, well, they know what the value is, so they'll use that value in the estimate of the query. And of course, that's not true. It matters where SQL Server makes the plan. And so the query processor always creates a plan, either on entry to a stored procedure or at the beginning of a batch. So in this case, what they're going to do is they're going to make the plan at the beginning of the batch. Why does that matter? It matters because at the beginning of the batch, they don't know this number, right? They haven't got to that statement yet. And so when they're making up a query plan, they're making up a query plan for this without knowing what the number is, right here like this. And so because they make up a query plan like that, which is, by the way, why you should always use parameterized stored procedures and pass the parameter value in, and the parameter value better be correct, right? Because if it's not, or if you don't do it that way, they're going to have to guess. By the way, if you write a parameterized query in ADO.NET and you use just regular parameterized SQL, they will change that query into SP execute SQL, which is a way to use parameterized dynamic SQL, and so they'll have the right value anyway. So if you're writing a program, that's fine. If you do this like this now, what they're going to do is they're going to say, okay, we're up here, we're creating the plan, and we don't know the value of this. So the value of this turns out to be way off because they use a heuristic guess right here. Oh, I missed the third one now. Okay, well, so this is let's go back one, sorry. And this is the same way except with an equal sign. Good, Bob. Okay, so this is the same way with an equal sign, an equality predicate. The other one was a greater than predicate. But this is the same premise, right? They don't know what this value is at the time they make the plan. So how do they estimate the value if they don't know what it is with an equality predicate? With an equality predicate, they assume a uniformity of distribution. And so what they do is look at the density statistics to create the plan. Because you know it's only going to be equal to one value. And how many unique values do we have for order date? 480 of them. So they'll figure that it's 830 divided into whatever the density is, and they will get an estimate of 6. And so here, they're actually using the density statistics. So to reiterate that babbling, if they have an unknown value with an equality predicate, they will use the density statistics. And they don't maybe get the exact estimate, but they get when it's close. Here we go. And why don't I need when 1 equals 1 here? Because it's already parameterized, sure. And so notice here, there were 6 rows affected, and they actually guessed 1.72. So that wasn't that great, right, to be able to do that. Apparently it wasn't uniformly distributed. Okay, and actually 830 divided by, well, you can work it out, it's probably 1.72 something. But remember, the new cardinality estimator is supposed to be better. Now let's go back to the other one, which I babbled on about for too long. When they have an inequality predicate, there's no way to use the density statistics, right? And so what they do is they make a heuristic guess. And the heuristic guess is 30% of the rows in the table. That's what they always guess. So inequality with an unknown value of a parameter is 30% of the rows in the table. So there's 830 rows in the table. They will estimate 249, and they actually get 676. They're way off. Let's see if the new card, this is the new cardinality estimator, so let's see if they can do better. This is 676, and no, they're still estimating 249. And so we can prove this with a trace later on, if you want to see the trace. Of course, everybody wants to see the trace. Okay, so anyway. So in our estimation example, we use statistics, and statistics show that a range high key is the best. Average range rows is an interpolation between the range rows based upon the number between the range. Density of the entire column, which is 1 over the number of distinct values, and a hard-coded guess. When it's parameterized, the value is unknown, and you're using an inequality predicate. Okay. So that's how the estimator works for easy things. So why would they make a new estimator in the first place? Sounds like it's going to use the same rules, or is it? So the old cardinality estimator was introduced in SQL Server 7. That's how old it is. And extensions were added to it over time. Now, starting in SQL Server 2005, or right between SQL Server 2005, they changed their pattern a little bit. The pattern before 2005 was to put changes to the cardinality estimator and query processing changes in when they found what they thought was a bug. And so when they put these in over time, what happened is they found out that customers hate plan regressions most of all. In other words, what's a plan regression? I have a query, it took 2 seconds, it worked fine. I put on Service Pack 1, that same query took 10 seconds because it got a different plan. I can't figure out how to hint it back to the old plan, and so you just messed up my query, right? That's a plan regression. And basically the idea is, any change to the cardinality estimator or any of this stuff that you put in, 98% of the people will get better or the same plan, but I'm always in this 2%. So you ruin my plan over time. So because they hate plan regressions most of all, starting in SQL Server 2005, they decided that they wouldn't do that anymore. If they made changes to the cardinality estimator or if they had query processing bugs that they would fix. So it didn't affect the answer, right? If you got the wrong answer, they put it in right away, of course. But if you have ones that don't affect the answer, then what they would do is they put them in through trace flags, right? And so what ended up to be by the end of 2008, 2012, was they had 1.5 million trace flags, right? One for everything under the book. And so you would hire a consultant, and the consultant would say, oh, well, you look like you should put on this trace flag and this trace flag, but this trace flag doesn't work with this trace flag, and this one, negates that trace flag. And so it was a big hodgepodge, right? These were also hard-coded in the code, right? There was no table of, if you use this trace flag, go here. They would just take different code paths. So over time, it became difficult to predict, understand, or control. In fact, I started to look into this by actually reading a white paper that was put out by the people that tested the new Cardinality Estimator. And they were trying to describe how the old one worked. And they were trying to describe how it worked for something like, I thought should be simple, called joins. And they basically said, the first thing we do for a join is to try and match up the histograms. And then the second thing we do is to look for foreign keys. And then after that, and these are the people that wrote it, right? After that, or the people that test it. After that, it is too complex to describe. It's like, really? That has a lot of faith in that, right? So anyway, over time, it sort of got out of hand. So they had introduced a couple of the more famous trace flags. And this one here you can actually read about in a guy named Ian Jose's blog. Ian Jose was a guy that actually worked on the query processor and the Cardinality Estimator. And in trace flag 2301, he actually changed a couple things. The ones that I can probably describe quickly are integer modeling and comprehensive histogram usage. Base containment assumption I'll get to later on. But integer modeling says, you know how they interpolate between two values if you don't have range high keys? Well, remember that I said that it looked like that every date had a 0 time, and so they were interpolating based on the fact that you could have seconds even though you may not. Well, they would do this with integers too. So if I have an integer 4 over here and an integer 7 as my other range high key, even though the data type was typed integer, they basically would estimate parts of integers. It's like, that's silly because that's a value that could never be. So they changed the integer modeling to be more correct. Also, histogram usage. If the selectivity got below a certain percentage, they wouldn't use the histogram anymore. They just guess. And so they were using the histogram more of the time with this trace flag. Okay. The other famous trace flag is the one with the ascending key problem. And at the pre-con on Monday, I actually described the ascending key. Actually, I didn't describe it. There was a guy in the pre-con that actually described to me, so how does it estimate if you do this? And it's like, oh, that's a very famous problem, right? So suppose you have an index over an ever-increasing integer column, like an identity column, or an ever-increasing date column, right, where it's just the current date every day. How do they do that? Because remember, they're going by these statistics. And so the statistic says that the highest range high key is the value at the time that I updated the statistics. So if I update the statistics on the 1st of April, then the highest key I can possibly have is the 1st of April. But if I put in 1,000 rows on the 2nd of April and query for them, how many rows do they think there should be? Well, the statistics say none, right? By the way, they can never estimate none. So they estimate 1, right? And that's going to be wrong. It just so happens that you haven't updated the statistics yet. So this is called the ascending key problem. And it happens with in identity or sequence, but worse is that it happens with dates, right? Because you can add a lot of the same date, right? If it's the order date or something like that. So what they introduced for this was a special set of trace flags, and there's 3 of them actually rather than 2. The first trace flag, 2388, basically says that they will change how they look at the statistics and display them. The second one, 2389, says they will look at every where clause, and if the value seems to be going up that you're querying for, and the value seems to be going up in a statistics update, they will brand that column as an ascending key column. 2390 says, never mind, we'll brand every column as an ascending key column. So I wanted to show you an ascending key thing before the new Cardinality Estimator. And this is the best demo of this I've seen, and I didn't write this demo. It's written by a guy named Benjamin Navarez, and I think I pronounced that right. And I asked him if he minded if I used it, as long as you use my name. Okay, so let's see we'll just go back to the demos we have, Bob. It's in the scripts that I have. And by the way, I'm going to post these scripts someplace, and if I don't, you can hit me up next week for them. I'll send them to you. You can show your friends. Okay. So this is in, goodness, right here, the ascending key problem. And this is where you can read about his thing if my description of it isn't good enough. So in AdventureWorks 2012, and by the way, before we even start this, we have to make sure that AdventureWorks 2012 is using the old cardinality estimator. So how in 2014 they decide if you want the old one or the new one? And the first thing they do is they look at the database compatibility level. And if the database compatibility level is 120, it's a new database, then they use the new one. And if it's less than 120, they use the old one. So what I have to do to make sure I get the right answer here is to go and change this compatibility level back to make sure they're using the old one. So right here, notice it says compatibility level 120. If you restore an old database to a new version, or if you attach an old database to a new version, it maintains its old compatibility level. If you define a new database, it has a new compatibility level, sure, with DDL. So we'll push it back. By the way, you can push back a new database to an older version too if you want. So there you go. So now we'll drop this table and create this table. Fine, it's not there. And create this table. This hideously big font, I can't probably do too much. There we go. You can see a little bit of that. And so it's just a table with a lot of columns. And what it is it's mimicking another table that's already there. So what you can then do is do select into or insert select. So insert into this new table, select from the original table, but I only want rows that are before July 20th. Okay, good. So I have July 19th and below, or July 20th, below July 20th. And there's all the rows, and now we'll create the index over that. There we go. And when we see the statistics, you should see that they look similar to the ones we saw in Northwind. There we go, right there, and there's the histogram. And if you go down to the bottom of the histogram, the bottom of the histogram, of course, reflects the last day before the 20th, which is the 19th. That's the highest value they can find. Notice they're doing the same thing here where they should be using a date data type, but they're using a date time and giving everything 0 time. So that's fine. All right, so there. So when they actually do a query, so we'll do a query against the 19th, they get the perfect answer because they have statistics. So there we go right there. We notice the estimate over here should be, 35 rows. And they estimate 35 rows, they get 35 rows, perfect. Now what they're going to do, of course, is to put in some more rows that are off the end of the statistic. So you can go here and insert new data for data on the 20th. Remember, the statistics gave out at the 19th. So this is data, since there's not enough of it to update the statistics, this is data that are not in the statistics at all. So if you were going to estimate how many rows, how many would you estimate? 1. So if we go look for these, they don't go by the assumption that if you're querying for a value, it must be there. So instead what they'll do is they'll estimate 1. I believe, what did I insert, 30 or 35? So this is estimated number of rows of 1, actual is 30. They're way off. So SQL Server is keeping count. And once you put this trace flag on there, keeping count. And so we're going to turn on the trace flag to change how statistics display, and the one to actually start keeping count to see if it's an ever-increasing column. Notice if I wanted to just give up, I could put on 32, 23, 90, and it would think everything was an ascending column. Okay, but once you put those trace flags on, you can see that the statistics display changes. Notice that by default, I only get the first statistic, the summary column, but notice it's different. I've got rows above, rows below, squared variance error, and I also have something that calls leading column type. And it can either be unknown or ascending. So let's see how long it takes him to figure out it's an ascending column. Okay, and it's actually supposed to be 3 statistics updates where you insert new rows. So we'll update them with full scan, and now we'll do a second batch of inserts. So now we'll insert the 21st. I'm basically just going 19th, 20th, 21st of the thing. This was a really good thing. I think I wrote him mail saying this is a really nice way to illustrate this. Because Ian Jose actually will talk about how it works in the abstract. Ben wrote this lovely demo. Okay. So anyway, there we put in a batch. And now it still estimates one row. And it still doesn't know if you look at the statistics. One row over there. It still doesn't know if you look at the statistics that it is not an increasing, or not increasing how long. So if we go look at them now, it still doesn't know. So notice that you get one row for every time you updated the statistics now. So it's still unknown or null here. So let's update it once more, and then insert a third batch, and update them again. There. And we update them again. When we actually go look at the statistics now, it says that finally the leading column type is ascending. So after 3 sets of ascending inserts plus statistics updates, they will decide that that statistic is ascending. Everybody okay with that? The problem was that you still had to put trace flags on, right? And so this wasn't the greatest thing. By the way, it won't be finished until we actually see that they actually did guess the right thing now. So let's try this, the 23rd. Because remember, the last thing we did was an update statistic. So now let's see if we can find the 23rd that we just put in. We put in 30 rows, and so now if we query for the 23rd, we'll actually see that out of 30 rows that we know are there, it actually estimated 27.9 rows. So it didn't get it exactly right, but it came close. And how come it didn't get it exactly right? Well, there's no statistics really out there. They're guessing based on the density. They're extrapolating based on the density. Everybody okay? So there was 2 things that they put in that were sort of famous, and they put these in with trace flags. So now again, you start to wonder which trace flag do you ever run. So it turned out that over time, there appeared to be so many trace flags that people got confused. So they did something that some people like and some people hate, which is they put in the uber trace flag. Right, the trace flag that encompasses all other trace flags. And that's trace flag 4199. So I have to guess, besides Klaus, how many people knew about trace flag 4199? No? I thought it was fairly well known, but you remember who I hang out with, right? So 4199 is the trace flag that has all the preceding trace flags. And pretty much if they have anything that's new, they'll incorporate that in 4199 as well. So basically the rule is, until 2014, if you don't get the right cardinality estimates, try it with trace flag 4199. It may work and it may not. It usually works better, but remember you can have regressions. You don't want to turn 4199 on for everything all the time, because some queries might get a worse estimate. There's already a guy from, I think, Slovenia or Austria that's actually come and figured out a way to fool the new query estimator to get the wrong answer. And so you can turn the new query estimator on and off. We'll talk about how. So this is where they introduced this lovely trace flag. And by the way, I used to do spatial support. If you had a spatial indexing problem or a spatial query problem, they would call Microsoft, and eventually I get this phone call that says, this is a weird problem we have. Can you help us with this? And so I did this for the last 3 years. The best thing to do right away is you ask the guy on the other end, did they put in trace flag 4199? No. Well, try and call me back. Right? So that's the easiest thing to do, especially with spatial. They have a hard time with spatial because really the cardinality estimator knows nothing about geography, and so they don't know what to do. Right? Basically what they should do is, the spatial index is so good, it makes things go so fast that they should always use it by default. And so over time they use it more and more. Anyway, that's the stuff. So you can put this on, you can see that these are all the ones that they support. Without internet, I'm not going to go there. But there's a list about as long as your arm of trace flags that they support under this, the uber trace flag. Okay. So in SQL Server, even before 2014, they allowed you to trace inaccurate cardinality estimation, and they did this with extended events. So people use Profiler, people use extended events. So in 2008, they put in extended events, right? And extended events is the thing that's going to kill Profiler. right? Profiler as of 2012 SQL Server is deprecated. It will eventually go away someday. And if it goes away someday, I'll believe it when it happens, right? Because a lot of their tools still use Profiler. And so, anyway, what they did is they tried to use this new thing called extended events. And what the extended events are supposed to be good for is they're supposed to be non-intrusive. Profiler can slow down the system a lot, right? And if you're actually tracing to look at the trace and also tracing to a file at the same time, you are actually doing true profiler traces. And so if you're tracing performance, well, any analysis that you do at a real-time system is always going to slow things down. It just slows things down a lot, right? Just look at your weight stats afterwards. The weight stat you'll get is, the biggest one you'll get is the one for profiler itself. Okay, be that as it may, right? They introduced these extended events as trace points in the code that were meant to be really lightweight. The problem is that they put out everything in the canonical format of the time, which was XML, right? Luckily, they didn't put them out later. We don't be reading JSON today. And I can at least read XML, right? JSON, not so much, right? I suppose you can read it, but I have a lot of things to query XML. So anyway, they put this event in. Oh, so right now, the new things after 2008, the features that they've added after 2008, only appear in extended events. So in 2008, there was 249, I think, trace, this is being recorded too, 239 trace events and 450 extended events. In 2012, they added no trace events and they added 400 more extended events. In 2014, I believe we're up to, and I have to check this to be sure, someplace around between 1,200 and 1,400 extended events. So if you're using any features that got introduced after 2008, it's not going to have a trace event, but it will have an extended event. So what are we tracing that we care about? Oh, file stream, file table, any of the 2014 features. Goodness, what's the one that it's been gone likes? But it's windowing functions, anything that's new, right? Okay. So there is an event, so I'm going to show you how to use extended events. Aren't you lucky? So there is an extended event that was added in 2012 that is actually called Inaccurate Cardinality Estimate. So the way you use extended events in 2012 and above is you get out SQL Server Management Studio and you actually use their GUI. The way you use extended events in 2008 is to actually code DDL. And DDL is fine, but you have to know what to put in there. There's not a big list and you choose it. So I work with a guy named Jonathan Kahanis, and he actually has a CodeFlex project for something that integrates into SSMS to make a GUI for SQL Server 2008. And it works quite well. In fact, he prefers it, of course he would, he prefers it to the GUI that comes with 2012. But here's the GUI that comes with 2012. So under management, oh, and by the way, you can't use the 2012 GUI against the 2008 database. Too bad, I tried, right? So under management, there is extended events. There they are right there. And basically, extended events live in sessions. So what time is it, 12:23? Yeah, let's do this part first. And everybody knows how to do trace the least intrusive way through server-side trace queue. So extended event is like the server-side trace queue, and I can't do this. So let me illustrate server-side trace queue. I have to trace here though. So we'll have to find it. This was not a good path to go down, Bob. Maybe it was. Maybe this is more interesting than the thing I would have talked about. Okay. Where's there it is. So profiler. So the way most people use profiler is like this. Come on, profiler. Oh, there it is. The way most people use it is like this. Click, click, click. And it starts to run things, right? The best way to use profiler is like this. Click, new trace, fine. Select the events you want, right? Wow, this is such a hideously large font that I have to scroll, right? So select the events that you want, event selection, and then select only the columns you want. And then when you're done, you can run it, but then stop immediately. And the reason why you want to stop immediately is you have now defined a trace session. And so you don't want to run this so you can see it. You want to run this to a file. And then you want to put that file into SQL Server or look at the file. You can, by the way, open a file here so you can see the trace, right? Open a trace file. So you're not going to lose anything. You just aren't going to see these things in real time, right? And it'll be much less intrusive to do it this way. So now that you've got a trace defined of exactly what you want, then you go in and say File, Export, Script Trace Definition. And when you do that, you get a SQL file. So notice I've done this before, right? So there's already one that says trace. And what this is a set of DDL so that you can run trace to a file yourself. Where is that sort of thing? Oh, where did I put it? Nice. See, that's why you should have gone down this path, he said. There. It's in administrator documents. Oh, okay, it's one level up from where I thought it was. Sorry. So it's here. Okay. Now if I open that SQL, there it is. What you actually get is a set of SQL that says your file name goes here. And by the way, you have to put a real file name for this to work. Right? And so I'll put C temp and then Bob. And if I do it this way, it'll actually make bob.trc. If I put bob.trc, it'll make it bob.trc.trc, which is what I always get. But anyway, it also has to be a path that the SQL Server Service account has access to, because it's the service account that's going to run it, right? They're running SQL Server. And notice what this is. It's an SP trace create. And then they go in and actually code up the DDL for all the events you've chosen and all of the fields you've chosen. And then at the very end, it sets the filters you've chosen. And then it says, set trace status, trace ID 1. 1 means turn it on. So if you comment out this line, what you're actually going to get is a definition of a trace that lives in the master database. So if I do this part, ooh, what did I just do? I'm happy with that. Did I mess something up? What's wrong with, oh, this thing. There we go. Can't even type 2 minus signs. So go, here we go. Now it says it is made up of trace forming called trace number 2. Where would I see this trace? Well, that would be systraces, right? So select star from systraces. And in systraces, it's a list of all the traces that you have. And so what do I have to do? Well, if I want to start it, I just say sp trace set status 1. And if I want to stop it, I say set status 0. And if I want to delete it, I say set status -1. And for some reason, not only to the people who made this term up, this is called a server-side trace queue. No idea why. And so extended events live in sessions, which are similar in concept to server-side trace queues. That was a long way to go for that one statement. So a session is basically a set of DDL that defines an extended event trace, and you turn it on and you turn it off. So let's make one of these. You can make one in 2 ways. You can make one with the wizard, which actually makes a little wimpier session. Not terrible, but a little wimpier. Or you can do a new session, so let's do that. Looks just like trace. First thing is you have to give it a name, so my session. And you can have the same templates. There we go, right here. Or you can even make your own templates as XML and put them in the right directory and it knows they're there, just like, Profiler could do. And I'll start with a blank one. And then what I want to have here is a list of events. Now, the events are rather interesting because there's a million of them. Remember, they all come out in these categories. So the nice thing you can do is you can look for them and it'll, in real time, try and filter them out. Notice I was looking for an accurate cardinality estimate, and notice it's not there. Did I spell it wrong? No, they decided that in this trace product, they would actually use tracing that was more similar to the way Windows Trace works. And Windows Trace actually has 4 different categories they call channels of trace. So basically there's an administrative trace, an analytic trace, an operational trace, and a debug trace is for you to do when you're debugging a problem. And for some reason they didn't turn those on by default. So you do have to go to the right channel list and turn on the debug ones, and there we have inaccurate cardinality estimate. Right, if I wanted to change, for example, RPC complete, there's a bunch of things apparently that have RPC in them. Okay. So anyway, inaccurate cardinality estimate. There. And so I just push this over to there. Come on. Select it and push this over to there. And by the way, it tells you what this thing does. And the fields are, every extended event, trace event has different fields that do different things. Just like profiler, except they're not laid out across the top, right? So anyway, put that there, and then we'll go to configure it. And one of the things you can do is add optional fields. These optional fields are called actions. They call them global fields, apparently. They're called actions. And one of the actions that I'm going to put in with this one is the SQL statement we're working on. So there's the SQL text of the SQL statement, and I can add all kinds of lovely actions, which may or may not appear depending on what I'm tracing. And one of my favorites, and then I'll stop because it's already 12:30 about the trace, is the SQL stack. Did you notice you could get the transact SQL stack? Well, what's the SQL stack? If I have code that calls store procedure A, which calls store procedure B, which calls store procedure C, I can see up the stack. Cool, right? Of course, you get to see up the stack in SQL handles, which means you have to do a query to resolve them to SQL statements. And so I asked the extended event guys, so could you just resolve it to the statement for us? Because I can only resolve a SQL handle to a SQL statement if it's in cache. And they said, no, the linchpin of the extended events is that it's supposed to be non-intrusive. I said, well, give me an option. If I want it to be intrusive, I don't care. Anyway, so once you've done that, then you can choose what's called the targets. Oh, and by the way, you can filter everything, of course. You can choose what's called the targets. And of course, they have some interesting targets, like the obvious ones, like an event file. But there is also a Windows OS global tracing facility called ETW Trace for Windows. What's ETW Trace for Windows stand for? Goodness. Okay, ETW Trace for Windows. And so basically, you can trace SQL Server along with ETW trace of other things. What can you trace with ETW? Oh, ASP.NET, the Windows kernel, the disk, anything you could possibly want. You can actually trace client-side, and so you can correlate a client-side trace with a server-side trace, other weird and interesting things. So they have a target for that. They also have some esoteric targets. My favorite one, I guess, is called the pair-matching target. The pair-matching target says, you know, it's too much stuff to trace lock taken and lock released, or SQL transaction started and transaction finished. So what the pair-matching target does is say, you want two things, and when the first one starts, sorry, pair-matching, there we go. So when the first one starts, you begin with, and then when of course I only selected these, and then they put things out in a buffer. When the transaction starts, when the transaction ends, it erases the buffer. So what happens after a little while? You get a list of all the transactions that have started that have not yet completed, which is interesting, at least to me. Okay, then there's some advanced features, and we go on. And so basically, even in 2012, you can see inaccurate cardinality estimates. I'm going to concentrate on the 2014 ones, but that's what you can do with 2012. And so it actually fires on iterators that read rows. So for example, it'll fire on a scan or a seek, and that produce different number of rows than they consume. And it can fire, this event, can fire multiple times per iterator and multiple times per query. So suppose the estimate says that they're going to produce 6 rows, and you really end up producing 80 rows. What they do is they calculate an accuracy threshold at execution time. So let's see, if it's 6 rows that I expect, maybe the inaccuracy threshold will be 4, right? So what this does is that this will fire at row number 11, right? Because it's more than the threshold. And then once it fires once, they recalculate the threshold. So you don't get it firing at row 11 and row 12 and row 13. You get it firing at row 11 and row 21 and row 31 and so forth. So that's how this particular thing works. And it will show you the actual number of rows, but don't be confused. The actual number of rows that this shows is the number of rows returned so far by that iterator, not the total number of rows that eventually get returned. But this is a good way to see if you have inaccurate cardinality estimates. So what can you do? So you can have a new estimator. So in SQL 2014, which is what this talk was about, which is why I didn't do the other trace, in 2014 they have a new cardinality estimator. And by default what they do is go by the database compatibility level. If it's 120, it's the new estimator. Older compatibility levels, you use the old estimator. And you can actually see in query plans which estimator you're using. So, remember I was in Northwind when we're using the old estimator? So let's go back to my Northwind example. He said, where's my Northwind example? There. And we'll actually look at this query plan here. And if we look at the query plan, everybody likes to look at query plans by looking at hover over help. But there's only so much information you can cram into hover over help. And so a way to look at more information is to select the iterator you want with a click, left click, and then hit F4 to see all of the properties. And there's all of the properties. Well, if you see all of the properties to the iterator on the extreme left, the select iterator, one of those properties, he said, I'm getting to it, there we go. One of those properties is the cardinality estimator you use. And notice he's saying that this one is using the cardinality estimator 120, which, oh, that's right, it was AdventureWorks that I moved back to 110. Right, Northwind is using 120, AdventureWorks is using 110. But remember, the old cardinality estimator wasn't invented in 2012, it was invented in SQL Server 7. So if I do that same query against this guy, so we'll do this, and oh, we have a plan right here. So if we look at this plan against AdventureWorks, and I always like to select a few of them because sometimes properties is hard to get to work. There we go. The cardinality estimator here is 70. So 70 is the old one, 120 is the new one. Okay. There we go. Now, it says here that it's the compatibility level of the database, but it turns out that's not exactly right. It's not the compatibility level of the database where the tables live, because suppose you're querying tables of TempDB and you're querying tables of your database, right? A join between a temporary table and an AdventureWorks table. Which one would it pick? So what it actually picks is the compatibility level of the database from which the query executes. So if I use three-part names and I make a database called food, and I set food to compatibility level 120, and I query over to AdventureWorks from food using three-part names, it's actually going to use the compatibility level of food, not of AdventureWorks. Everybody okay with that one? Okay, that was an interesting find by the person that found it, so, which wasn't me. I don't do anything, right? I just read. Now, I'll show you what I did at the end, and you can be either impressed or amused. Okay. Now, in addition to that, you might want to not set it on or off all the time. So there's trace flags that you can use to control it. This one says use the new one all the time. This one says use the old one all the time. Well, the nice thing about that is there's a couple of different places you can put trace flags. You can put trace flags in startup, and that gets used by everybody all the time, right? That's just configuring the SQL Server to use a specific trace flag right here. This is configuration manager, and you go in here and you say properties and you say startup parameters. And if I put -T, whatever that was, 9418, then it would use that for everybody all the time, regardless of the database level. Or you can do what we did over here, which is you can set trace flags on a per session basis. So this guy is using, where's that trace flag? With dbcc command. There it is. So this guy, this session, is using the trace flag, but nobody else is. But better than that, they have just made this public. Apparently it worked for a long time. Better than that, there's a query hint that you can use. And the query hint that you can use, and you can use them on any query you want, is option query trace on, and then the number of the trace. So if you get a bad estimate and you want to see, well, maybe the Uber trace flag will work for you, just put option query trace on 4199 and you're all set, right? And that would use trace flag 4199 once, and you can see if you get a better plan or a worse plan. Everybody okay with that? So you can use this to turn these on, because remember, customers hate regressions worst of all, on a query by query basis. Cool. And again, the query plans show you which one you used. So the new estimator goals are, of course, consistent, predictable performance. Who wrote this was actually, this is an academic white paper. Actually sounds really good, right? Different operator trees that represent the same relation have the same estimates. Well, good. We can't branch off into different code paths and never come back. And there's a new model for better performance. Significant changes to the model result in more accurate, I'm reading this, cardinality estimates and better plan choices. And they incorporated all of the special case code into the new one. So basically, it's going to consider as if you might have that trace flag on, but it's not always going to use the trace flag. Okay. And it's easier to support, and of course, with minimal regressions. And if it really worked that way, well, it does most of the time. So how is it different? So the SQL 7 cardinality estimator was integrated right into the code. It was basically passed through the code, and like I said, 2 wrongs sometimes made it right, but not usually. And all the special cases were just integrated right in the code. And so you imagine spaghetti code, and I've never seen the SQL Server code, but maybe it is, maybe it isn't. The cardinality estimator in 2014 works in 2 distinct, discrete stages. One is that there is a set of cardinality estimating components. And what they do is they go through the query and they figure out which components they are going to use by name. And they make up a list of the components they are going to use. And there are about 50 choices for cardinality estimating calculators. They call them calculators. Once they figure out which calculators they're going to consider, then they execute those calculators. Those calculators you can imagine as objects in an object graph, and we'll just do this one and this one and this one. And that's much better, right? So they include also refinements to the basic assumptions, which are kind of nice because I didn't like some of the basic assumptions. So it's nice and clean now. Then we'll start putting trace flags in, right? Anyway, so the first one was independence versus correlation. So imagine I have a table with cities and states in them, and say, for example, you only have 1 state for every city. There is no goodness. See, in the US, this wouldn't work because in Canada, we have London, Ontario, and there's London, Oregon, and there's London. So it wouldn't quite work as well. But if you say New York in the US, it's probably talking about New York, right? New York and New York State. So columns are independent in the old one. So London, England would have 10%, 10%, that's 1%. In the new one, they use something called exponential backoff. And there's an exponential backoff algorithm whereas instead of multiplying A by B and coming up with a really low number, they're going to use an exponential subtraction from the original number. And so they'll come up with something that's closest to the real number. They assume some correlation. And by the way, that's with multiple predicates in the same table. So if I say A join B, where A dot city is equal to London and A dot country is equal to UK, they will use the exponential backoff. However, if they're in different tables, and you've designed the 5th normal form, then they will actually, if you have a thing that says where A dot city is London and B dot country is UK, they still use independence. Everybody okay with that? They also use, for the simple join, something that says assume keys in table A exist in table B. So there was a guy that actually had, where am I so far from time? Okay, I got 15 minutes, so I better not do that one. There was a guy who actually did a join between table A and table B. Table A had a foreign key to table B, and table A actually had 110,000 rows. And so basically he said, well, the join should produce 110,000 rows. By definition, it had to, right? And in SQL Server 2012, it produced 90,000 rows as an estimate. Of course, it did produce 110,000 rows. So in 2014, he actually used the new cardinality estimator on it, and it produced exactly the right answer, and he was happy. And he decided this was because of the foreign key. So I removed the foreign key, and it still produced 110,000 rows. So it's not necessarily the fact that you have a foreign key, it's the fact that they make the assumption that keys in table A exist in table B most of the time. The ascending key, they made that part of the thing, you know how that works. And containment, so if I have multiple predicates in join tables, they did something originally called simple containment. Here's an example of simple containment, and I'll repeat it if it sounds too obscure. Say you have a list of products and categories, and one of the categories you have is toys, and you're looking for only toys. Now suppose you have a list of sales, and the sales table has dates on it, right? So say I'm looking for toys that were sold in March. The old containment assumption said that toys is an estimate on one table, March is an estimate on another table, and they would make the assumption, I love this assumption, that all toys were sold in March. That's not a good assumption. Everybody gets that? That's not a good assumption. Right, so the new one says, I assume there are toys, and I assume there were sales in March, but not all toys were sold in March. Right, so that's the new assumption. By the way, you can make up queries to try and prove this to yourself, and it's really interesting. At least to me, right? I told you it's only interesting to me. Okay. So, of course I love this. You can trace cardinality estimation. And so what I wanted to show you was something I wrote 3 or 4 blog entries on called How to Trace Cardinality Estimation and how to see what the cardinality estimator is doing. And so there is a single X event called Query Optimizer Estimate Cardinality. So let's do this, and we'll do a trace. And you'll have to understand that I have already a trace set up because it's getting late. And all my traces go to T traces. So we'll go into T traces and delete one we may have there already. There we go, for something else. Because when I did this the last time, it's like, there's so many cool demos to do with this. I go, well, let's not do this demo. How about we'll try this? So I decided before I did this talk that what I would do this time is actually try the Northwind one that we know how it works, right? There's the Northwind one right there. And remember I said it was a hard-coded guess of 0.3? So let's see if that's true, or I'm just making this up. Now remember, you do have to be making up a query plan, right? If you're just reusing a plan that's out in the cache, you won't see anything. And you do have to be using the new estimator. The old estimator doesn't produce anything, of course. So there's 2 ways you can do this. One is on a test system, but not on a real system. You can free the prop cache, and then there are no plans in cache. The other way you can do it is to put option recompile in your query, and that says make up a new query plan every time. So what you do is option recompile. And you have to go to Object Explorer, and I would assume that my trace is called Cardinality, and I would probably be right unless I've gotten rid of all my old traces. There they all are, 1. And so here's the one called Cardinality, it's down, so we're going to turn it on. There. Now, by the way, you might get extra crap in here when you turn it on with the GUI. I always have something that says alter event session cardinality with status equals on, and turn it on like that. But I'm lazy and it's getting late, so we'll do it this way. But bear in mind, we could have whole stuff in there. Then do this, then turn it off. I bet you that's what causes the extra events. If you look at trace while you're using SSMS, especially if you have IntelliSense turned on, you can see how amazingly many queries it executes. Anyway, okay, so now we should have a trace out there. So there's a trace out there. And just like with Profiler, we can double click on the trace and we can see the events get loaded. Now, of course, they wanted to improve on the trace. So the events actually get loaded into SQL Server Management Studio. In addition to this, if I have a trace that's running, he said, if I have an extended event trace that's running, but not if it's not running, you can actually say, watch live data. And watch live data basically watches the data as it comes out, just like trace does. Right? So they wanted to make sure that people could use a trace-like thing if they wanted to. But if you do watch live data, realize that by default, you'll have to wait for 30 seconds. Remember, this trace is supposed to be unintrusive because the maximum time before they'll dispatch a buffer is 30 seconds, and they won't dispatch a buffer until it's full. So if you only get a few events, you won't see them for 30 seconds. You can put this down to 1, and of course it will slow down the system just like Profiler does. Okay, having said that, let's actually look at our trace events. That would be more fun. So you might look at this and go, well, that's a wimpy Profiler. I only got the name and the timestamp. Well, what you can do is, here's all the other fields down here. And so what I can do is I can look at the SQL text, and basically if I right-click, I can show in the table. Oh yeah, there's the junk. See, this is the thing that's executing in the background. The events I really want are down here, and there's only 2 of them, sure. And I can actually go through and look at the 3 event, or actually 4 event fields that are interesting. But what I'd rather do, rather than to do that, and by the way, if you're using the GUI, you can group them and aggregate them and stuff, it's very cool, but it's not an extended event talk yet. So what I'd like to do is I'd like to go in and actually read these with SQL. And the way you read these with SQL, he said, I got 10 minutes left now, is to go in and here's a analyze. Now, unfortunately, when you read the things with SQL, you're actually reading them from a function called sysfn.exe file target read file. And it's reading all the file and T traces that start with, actually it should be cardinality. And what you're going to get if you just select this, he said, is for each event, you're going to get a chunk of XML. Why? Because XML is the format that everybody likes. Really? Well, not really, but XML is the format that they assume everybody likes. There we go. And so you get interesting things about the event, but the event data itself is XML. And so you're stuck like copying and pasting in places and looking at XML. So this is where I realized, for the very first time, I've realized it since, that XML in SQL Server is not a programmer feature. XML in SQL Server is a database administrator feature, right? Because database administrators have to know how to write XML to take things apart. And so this is an XML query. It's actually not a really complicated XML query, but I'm going to take certain XML fields and I'm just going to make them columns in a table. Great. So let's do that. It actually looks much better that way, believe it or not. And there are actually 3 fields in every event that we care about. The first field, well, 4 if you count the SQL statement. So again, this is just some statement that SSMS is executing in the background. Here's the real statement that we want down here, right there. And so in this statement, there's the statement that we care about. There's something called a stats collection ID. We'll get back to that in a second. And for each time they use a cardinality estimator, you get the input relation. What's the input relation? It's the logical operator called select. And when you get the input relation for select, you get to find out what statistics they are using. This is the statistics collection for a base table, right? You can almost read these. This is completely undocumented, but somebody's worked with this way too much. And then the cardinality for that, the number of rows I have for that is 830. They got that from the counts, right? That wasn't hard. Okay, great. Now, after that, the table that I have is orders, and the column that I have is order date. So you could decode most of this stuff in your head for a while. The next one, though, is the calculator they use, the cardinality calculator. And basically, they said that this cardinality calculator was going to use the filter calculator, a type of filter calculator called calculator select column and interval, right? Because I was using an interval, right? Greater than sign. So this is one to calculate an interval. Now, when I use that calculator, what it says I get is a selectivity of 0.814 from the Northland orders table. The column is equal to order date, and the stats is equal to 6. So basically, it thinks I have a selectivity of 814. Actually, they should have stuck with that. That was better, right? Remember that in this query, I estimate 249, and I actually get 676. So I'm estimating 30% of the rows in the table. Okay, so there's one more piece of information that I can do that I can give them another chance, and this is the statistics collection. And so it'll point out which statistics collection they're using. They're using the filter on the statistics. And notice right here, there's where they get their 676. So they start off with 830 rows. They try and calculate them and they get another number. And finally, they come up with this number. Right? And I'm surprised because I don't see the 30% anywhere. Well, let's look at the next event. The next event is a logical operator with a select through the index. The index still gets 830 rows here. There's no calculator that they're using because they're going to make a hard-coded guess of 676. There's some place in here that I should see that 30%, but I'm surprised I don't see it. Did you see the 30% is up my line? I have to go back and look again. Right. But you see where they get the 676. You can see which statistics they use. You can see which statistic type they use. That's a type of statistic. And then on some of the fields, which cardinality calculator that's not the right one. Cardinality calculator they use, this one here. The C-cell calculate column and interval. Okay. Now, having said that, you can also go back to the query plan. Let's go back to the query plan right here. Okay, and if I go back to the query plan, if I have the trace on, which I did, when I ran this query, there's more information in the plan. And so if I look at the plan, and I look at the properties of the plan, that's just F4, right? I get the extended properties of that iterator over here. One of the extended operators that show up, if and only if you're running that trace, is something called, he said, whoops, that's nice, go to the desktop. Something called the stats, well, let it all show, please. There we go. The stats collection ID. And there's the stats collection ID right there, stats collection ID number 2. And what's that good for? Well, stats collection ID number 2 can be correlated to the trace events. So if I go back to my trace events again, he said, come on, there we go. We'll get rid of this. We'll get rid of this. There it is right here. You can see that each of these rows had a stats calculation ID, and that's the one that they used, and that's the way that they calculated that number. So you can look at this and see what they're doing once you learn to decode them. And I'll write some more blog entries, and other people are writing them as well. Josac has one where you can actually see the exponential backoff being used, and use it to calculate the exponential backoff formula that they use. Right? And you can correlate them to a trace, a query plan, to see where they show up in a query plan. Everybody okay with this? So I was intrigued, mostly only me. I got 4 minutes left to go. Right? So basically what I did was I went through and I tried to produce every possible value of everything that I could produce. Now, I'm not finished with this yet, and it turns out after I did this for a while, I cheated, right? So I started to see patterns in what they were looking for, right? Those C-cell ones and C-stats ones and all that. And so there's a program by sysinternals called strings.exe. And what you do is you run this program and you point it in exe, and it puts out all the strings. So it put out a collection of strings. I now have all my calculators by name, and I went to try and produce each one. So far, I've produced them all except for the residual calculator. I'm not sure what that's used for. And what I'm going to do in the near future, if I enjoy it as much, is to actually try and decode these things and tell you what they stand for, one at a time. Because that's just the big calculator types. Remember what type were we using before? The filter calculator? Which filter calculator were we using? One of these. Now, these are just strings in the data, in the exe, but I've actually produced more than half of these with experimentation. Just try with all the different queries you might have. And of course, if you had a real workload, which I don't, you could run it against the real workload and see what gets generated. So for example, SQL Server with a data warehouse query will use something called a bitmap filter. And so there's one over there. There's the ascending key, by the way, right there. Notice here's a join with an ascending key, but here's a filter with an ascending key. So I know how to produce that one, right? That's pretty easy. Where's the exponential backoff? Oh, right here. C-cell cal combined filters with an exponential backoff. What's the remap one do? If you have a, goodness, Ian Jose blog mentioned that. If you have something with a convert, it will actually try and calculate them, and then do the convert and try and calculate them again, remap. I like this one, C-cell filter with residual guess. Or what was the other one that was interesting? Oh, C-cell calc with a pure hidden side. What does that mean? I haven't got that one yet, right? Oh, and there's our tray, right? It's spelled T-R-I-E. So C-cell calc tray-based. So depending on how much time you have and how bored you are, you can actually play with this for days. Sorry, I played with it for weeks. So, okay. So I produced, like I said, more than half of these. And then this is a list of, he said, the different statistics that you can use. My favorite one is what? Oh, C statistics column fudge, right? Just fudge the statistics a little bit and try again. Or this would be one for a string table valued function, or this would be one for a union all. And they use the statistics in different ways for different SQL constructs. You would think that if you put in the right construct, like outer join, you would see them for an outer join, but not always. I like, oh, C-stat call black box, right? Remember that they just released the source code for Windows and for Word a couple of days ago? And people have already posted big things about the nasty comments in some of the code. You know, the fact that, oh, labels in the code like this is a kludge and assembler, you know, stuff like that. So these are fairly interesting. Or I like filtered stats shim. So you know that filtered statistics were added, right? Because they have to shim them into the calculator. But by doing this, they're being more constructive about it. They have a set of things that they can use, a set of formulas, and they basically choose the formulas, and then they basically figure out which ones they're going to use, and then they apply them, and they come out with a guess as to which one, or a selection as to which one is the best one. So that, with less than 5 minutes left to go, is the, and really that's all there is, right? Oh, query plan, you already saw the query plan, right? The only way you get the stats collection on D is to have the trace running and calculate, have the extended event trace running and calculating that particular event while you have the query plan turned on. And by the way, that event is a debug event, so don't forget to turn on the debug event channel, else you won't see it. And so you can correlate these to say which trace records refer to each iterator. By the way, the first time I tried this was with a 5-table join. The 5-table join actually produced, I think it was 60 of those events. And actually only some of the numbers obviously correlated to iterators. So again, if you like this stuff, you can either do one of two things. You can go home and play with it forever, or you can wait and read my blog entries and other people's blog entries. Are there any questions? This is the thing they did in 2014 for everybody. You don't have to need a column store index. You don't have to need an in-memory database. Everybody uses queries, or else you wouldn't be using a database. Okay, well, if nobody has any questions, Klaus, you got any? No? Okay, so if nobody has any questions, I'll declare time for lunch. Thank you for coming. Oh, and I'm supposed to remind you again to use that app. Use the app to do ratings. So, use the app. Thank you for coming. Thank you. And if you want to hear about, what is it? Go ahead and clap right here. If you want to hear about, goodness, whether or not you should use an Azure VM or Windows Azure SQL database, I'm doing that at the end of the day. And if you don't want to do that, tomorrow I'm doing even things that are more esoteric. At 9 o'clock in the morning, I'm doing spatial, because I like spatial. And there's a lot of people that do. And then at the end of the day tomorrow, which we'll see how many people we get at this talk, I'm going to be doing Hadoop, Microsoft's implementation of Hadoop. Because you've got to find more interesting things to play with. You can only get so much of the cardinality estimate. Okay, well, maybe I'll see you tomorrow, maybe I won't. If I don't, thanks for coming, and I hope you enjoyed it.